Hey everyone, welcome back. Ready for another deep dive?
Definitely.
Awesome. Today we're going to be looking at something called Easy Java Simulations,
Ooh, interesting.
or EJS for short. And let me tell you, it's pretty darn cool.
I'm intrigued. Tell me more.
Well, you know how sometimes science, especially physics, can feel kind of, abstract.
Oh, yeah, definitely.
Like it's hard to really wrap your head around those concepts.
It can be a bit much.
Right. Well, EJS is this amazing tool that can make learning about pretty much anything way more hands-on.
Oh, so it's like taking those concepts and turning them into something you can really
You
experience.
got it. Instead of just reading about gravity, you could actually see planets orbiting a star
Wow.
and even play around with different variables like, changing the mass of a planet to see how it affects its orbit.
That sounds super cool. So how did you come across this EJS thing?
I was checking out this webpage about it, and honestly, just skimming through it, I was blown away by all the different types of simulations you can create.
Like what? Give me some examples.
Well, it's not just limited to physics.
Okay.
We're talking chemistry, geography, even games.
Hold on, games too?
Yeah. It seems like the possibilities are pretty much endless, and that's what got me so excited to dive into this.
I can see why. So it's not just for like super techie people.
Not at all. That's one of the best things about EJS.
Oh.
It's designed with both teachers and students in mind, so you don't have to be a coding expert or anything to use it.
Wait, so you're saying I could create these simulations without having to write code?
That's exactly what I'm saying.
No way! How is it even possible?
Well, EJS kind of takes care of all that complicated stuff behind the scenes.
Huh,
It
interesting.
lets you focus on the actual science.
Okay.
The concepts you want to teach or learn,
Right.
without getting bogged down in lines and lines of code.
So it's like a simplified way to get to the good stuff.
Exactly. Like a virtual lab where you can set up experiments and explore all these different scenarios.
Okay, that's starting to make more sense, but I'm still kind of fuzzy on how it actually works.
Right, that's fair. So let's unpack that a bit.
Please do.
It uses what they call a visual interface, right?
Visual interface.
You can drag and drop different elements to kind of build your simulation.
Oh, that sounds pretty user-friendly.
It is. Think of it as building with virtual Lego blocks.
I love Lego.
You and me both. They have this whole library of elements that represent things like, physical objects,
Right.
mathematical functions, even graphical displays.
So you could like build a simulation of a swinging pendulum just by dragging and dropping the pieces.
Exactly. You set the parameters like the length of the pendulum or its weight,
Uh-huh.
and EJS takes care of the rest.
That's pretty impressive. But how does it know, like, the actual physics behind the pendulum swinging?
That's the coolest part. You actually define the mathematical models that govern your simulation.
So you're basically telling EJS the rules of the game.
You got it. For the pendulum, you tell EJS, hey, here are the equations that describe how gravity and the pendulum's length affect its swing.
And then EJS uses those equations to actually calculate how the pendulum moves.
Yep. Like you're setting up a virtual experiment, and EJS is running the numbers for you.
That's amazing. It sounds like it's doing a lot of heavy lifting in the background, which frees you up to, like, focus on the big picture.
Exactly. You can get creative with your design.
Yeah.
Really focus on making your simulation super educational and engaging.
Okay, so we've talked a lot about the basics of EJS.
We have.
But what really excites me is the potential for making simulations truly interactive.
Oh, for sure. That's where things get really cool.
So spill the beans.
Yeah.
What kind of interactive elements can you add?
Think about adding sliders that let users adjust parameters in real time.
Okay, so like with your pendulum example, you could have a slider to change the length of the pendulum.
Exactly.
Yeah.
And then people could see how that change affects the swing. You could even add buttons that trigger different events or have input fields where people can type in data and see how it impacts the whole thing.
It's not just watching a pre-recorded animation then. It's like a truly dynamic environment where people can actually play around and experiment.
Exactly. And that's what makes EJS such an incredible tool for education. It takes people beyond just watching or reading about a concept and lets them get hands-on and really explore how it all works in practice.
So if I'm getting this right, EJS is like this super versatile tool that can be used for all sorts of different things.
Absolutely. And the webpage we're looking at lists a ton of different examples.
Oh, like what?
I mean, we're talking about things like exploring optimization,
Mm-hmm.
interactive pathfinding, even visualizing Einstein's theory of special relativity.
Whoa, Einstein. That's getting pretty advanced.
I know, right?
So it's not just for teaching like basic physics concepts.
Nope, not at all.
Yeah.
It seems like you can use EJS to explore all sorts of different topics and concepts, whether you're interested in basic science, advanced algorithms, you name it.
This is fascinating. I'm definitely seeing the possibilities here.
Me too. And what's really awesome is that EJS can even be used to create educational games.
Wait, games? You're kidding, right?
I'm totally serious. There's one example on the website about creating a typing game using EJS.
A typing game. I never would have thought of that.
Right, but it's such a cool example of how you can use EJS to make learning fun and engaging.
Because who doesn't love games?
Exactly. You can incorporate all sorts of game mechanics,
Yeah.
tap into people's natural desire to play and compete.
Which can make learning a lot more enjoyable.
I think a lot of us wish we had learned physics this way back in school.
Oh, absolutely. I know I do. It sounds like EJS could really revolutionize how we think about learning and teaching.
I think so too. It has the potential to make learning more accessible, engaging, and just plain fun for everyone.
That's a powerful combination for sure.
But before we get too carried away,
Yeah.
I know some of you listening might be thinking, this all sounds cool,
Yeah.
but is it really something I could use?
Right. It can sound a bit intimidating.
And that's a valid question.
Yeah.
So in the next part of our deep dive, we're going to get into some of the nitty-gritty details
Okay.
and show you how EJS can actually work for regular folks
Sounds good to me.
who may not be coding wizards or anything like that.
I'm looking forward to it.
So if you're intrigued by the idea of bringing these complex concepts to life
Yeah.
through these really cool interactive simulations,
Uh-huh.
stick with us. We're just getting started.
Can't wait. Welcome back, everyone.
All right, so we left off talking about how amazing and versatile EJS is.
Right?
But let's be honest, when you first hear about all the things it can do,
Yeah.
it can sound a little intimidating, right?
A little bit. Yeah.
Like all this talk about simulations and mathematical models.
It can make your head spin a little.
Exactly. So let's break it down and make it super clear.
Okay.
How does EJS actually work, especially if you're not like a coding whiz?
Yeah. That's the big question, isn't it?
Well, the good news is that EJS uses this really cool visual interface
Visual-
called a drag and drop interface.
Drag and drop. I like the sound of that already.
Right.
Uh-huh.
Imagine you have this virtual toolbox filled with all these different components like springs, planets,
Planets. Cool.
even graphs and charts.
Wow.
You literally just drag these elements onto your workspace
Okay.
and connect them to create your simulation.
So it's kind of like building with virtual Legos.
Exactly.
Yeah.
That's the perfect way to think about it.
That makes it much less scary.
Right. And just like with Legos, you have all these different pieces.
Right. All different shapes and colors and sizes.
You can combine them in tons of ways.
Yeah. To build whatever you can imagine.
And that's exactly what EJS lets you do.
Huh. So I could, like, build a car with these virtual Legos.
You could. Or a rocket ship,
Awesome.
or even a whole solar system.
No way.
EJS even has elements that represent mathematical functions.
Okay.
So you can really get into the nitty-gritty of how things work.
But how do you make sure that, the simulation is actually accurate?
That it's reflecting the actual science.
Yeah, that's what I'm wondering.
Well, that's where the real magic of EJS comes in.
The magic. Tell me more.
You get to define the mathematical models that control your simulation.
Mathematical models, huh? Sounds complicated.
It's not as bad as it sounds.
Okay, yeah.
Think of it like setting the rules of the game.
The rules. Oh,
So for example, if you were simulating a pendulum swinging,
like we were talking about before.
exactly, you would tell EJS, hey, here are the equations that describe how gravity and the length of the pendulum affect its swing.
So you're basically teaching EJS the laws of physics.
You got it. And then EJS uses those laws
Mm-hmm.
to calculate how everything in your simulation will behave.
Wow. So it's like setting up a virtual experiment.
Exactly. And letting EJS run the numbers for you.
That is so cool.
And you don't even have to be a math whiz to do it.
Oh, thank goodness.
EJS guides you through the process
Yeah.
and makes it super straightforward.
So it's handling all the complicated stuff behind the scenes.
Exactly. Like it's doing all the heavy lifting.
Yeah.
So you can focus on the fun part.
The fun part.
Designing a really engaging and educational simulation.
And then on top of that, you can add all those interactive elements we talked about.
Right, like sliders and buttons.
Yeah, to make it even more immersive.
For example, let's say you're building a simulation to teach students about force and acceleration.
Okay.
You could add a slider that lets them change the amount of force applied to an object.
And then see how its acceleration changes.
Exactly. Or you could even have a graph that updates in real time
Oh, wow. That would be
to
cool.
visually represent the relationship between force and acceleration.
That's really neat.
The possibilities are pretty much endless.
I'm starting to see how this could really change the game for education.
Oh, absolutely.
Yeah.
Students aren't just passively absorbing information anymore.
Yeah.
They're actively experimenting and discovering things for
It's
themselves.
just way more engaging.
And when students are engaged,
Yeah.
that's when real learning happens.
So you mentioned before that EJS generates Java code.
Right.
Does that mean you need to know how to code in Java to use it?
That's a great question. And the answer is no.
No, really.
That's one of the brilliant things about EJS.
Okay.
It takes care of all that code generation for you.
Huh.
You don't actually need to know a single line of Java code to use it effectively.
Hold on. So even if I don't know anything about coding,
Yeah,
I can still create these amazing simulations.
you got it.
Yeah.
It's like EJS is a translator.
A translate.
It takes your visual design
Yeah.
and those scientific models you've defined
Right.
and translates them into the Java code needed to run the simulation.
So it's like I'm speaking a different language?
Kind of a visual language.
Visual language.
And EJS is translating that into Java for you.
That's incredible. It makes it so much more accessible to people.
Exactly. No matter your technical background,
Yeah.
EJS makes it possible for anyone to create these incredible interactive learning experiences.
I love that.
And to make things even better, EJS is free for educational use.
Free. Awesome.
And the simulations that people create with it are often shared under open source licenses
Open source, so that means anyone can use them.
and modify them and adapt them to their own needs.
That's so cool. It's like a giant pool of resources.
Exactly.
Yeah.
And there's a huge community of educators
Uh-huh.
who are creating and sharing their EJS simulations
So people are constantly building on each other's work.
and collaborating and learning from each other.
It's like a global classroom for EJS.
Exactly. And there are tons of resources available online, forums, tutorials,
Yeah.
to help you get started and really dive into the world of EJS.
So it's not like you're just thrown into the deep end.
Not at all. There's a whole community out there ready to support you.
That's so reassuring.
So we've talked about what EJS is and how
Yeah.
it works.
And how it's not as intimidating as it might sound.
Right. But now let's step back for a second
Okay.
and think about the bigger picture.
The bigger picture.
Okay. Why should anyone care about EJS?
Right. What's the so what of all of
What's
this?
the real world impact?
That's a great question.
Well, for one thing, EJS makes learning more effective
More effective, how so?
because when you're actively involved in the learning process,
Right. Not just passively listening.
you understand and retain information much better.
It's like the difference between reading about how a bike works and actually getting on one and riding it.
Exactly. You learn by doing, and that's what EJS allows you to do.
Even for concepts that seem really abstract.
Right. Even for things like gravity or electromagnetism.
You can actually experience them.
And it's not just about making learning easier.
No.
It's about sparking that sense of curiosity.
That aha moment.
Exactly. When you can play around with a simulation,
Yeah.
you're not just memorizing facts.
Just asking questions.
You're experimenting, you're discovering things on your own.
That's when learning becomes truly exciting.
Absolutely. And EJS makes that kind of learning accessible to everyone.
Accessible to everyone.
It doesn't matter if you're a student struggling with a difficult concept.
Or a teacher trying to find new ways to engage their class.
EJS can help.
It's a tool that everyone can benefit from.
I think that's a great point to transition to the final part of our deep dive.
Okay, what's next?
We've seen how EJS works and what makes it so special.
Yeah.
Now let's zoom out even further
Zoom out.
and talk about the implications of EJS for the future of education.
The future of education. Exciting.
What role can interactive simulations play in shaping how we learn and teach in the years to come?
I can't wait to dive into that.
We'll explore all of that and more in the next part.
Sounds good to me.
Welcome back to the show.
Yeah.
So we've spent a good chunk of time talking about EJS, like what it is, how it works,
Yeah.
all those cool features. But now I kind of want to step back and think about the bigger picture.
The big picture. Okay.
Like, what does EJS actually mean for education?
Ooh, that's a good question.
You know, for so long, we've kind of accepted this idea
Uh-huh.
that learning science, especially physics,
Oh,
is supposed to be hard.
right. Like you got to suffer through it.
Yeah, like there's this badge of honor for struggling through equation.
And abstract concepts.
Exactly. And if you don't get it,
Yeah.
well, maybe science just isn't for you.
Which is so not true.
Exactly. And that can be really discouraging for a lot of students.
Especially for those who might not be like naturally drawn to math and science.
Right. But with tools like EJS,
Yeah.
we can change that. We can make learning more accessible.
More fun too.
Absolutely. And dare I say, even enjoyable.
There's that word again, enjoyable. I like it.
Think about it. Who wouldn't be more excited to learn about gravity?
Oh, okay, gravity.
If you could actually see planets orbiting a star,
Ooh, that would be cool.
right? You could even change the mass of a planet and
Yeah.
see how it affects the orbit.
Wow.
Suddenly, it's not just some boring formula in a textbook.
Right, it's like a game almost.
Exactly. And it's
Yeah.
not just about making things easier to understand.
Yeah. What I
It's about
love.
sparking that curiosity.
Oh, I see.
When you can actually play around with a simulation,
Yeah.
you're not just memorizing facts.
Yeah.
You're asking questions.
You're like a little scientist.
Exactly. You're
Ninja.
experimenting. You're making discoveries.
That's awesome. So it's not just about making science less scary, it's about making it more engaging.
Totally. And that's what I think is so powerful about EJS.
Yeah.
It has this potential to personalize education.
Personalize, huh?
It's not a one-size-fits-all approach.
Right, because everyone learns differently
Exactly. It can cater to different learning styles.
and different paces.
Yeah, some people might need more time with certain concepts,
And some people might want to dive deeper into specific topics.
and EJS allows for that.
Huh. It's almost like having a personal tutor.
Right. And as technology keeps evolving, I can only imagine the possibilities.
Like what?
Think about simulations that can adjust the difficulty level based on a student's progress,
Oh, that's cool.
or even provide personalized feedback.
Wow, that would be amazing.
It feels like the future of education is unfolding right before our eyes,
It really does.
and EJS is playing a big part in that.
I totally agree.
It's not just a piece of software.
It's a whole new way of thinking about learning.
Exactly. As we wrap up our deep dive today,
Yeah,
I just want to say I'm genuinely excited about all the possibilities.
me too.
It feels like EJS has opened up a whole new world of learning.
It has, and it's a world where learning is fun and engaging and accessible to everyone.
Absolutely. And that's something we're celebrating.
Couldn't agree more.
So thank you so much for joining us on this journey.
It's been a pleasure.
We hope this deep dive has inspired you to explore the incredible world of EJS.
And the amazing potential of interactive simulations.
And remember, keep asking questions, keep experimenting, and keep diving deep.
Until next time.